So today our lesson is on equivalent ratios. Equivalent meaning equal, being that base word, and ratios being that comparison of two things. So in this example we have behind here, we're comparing 5 boys to 15 girls. Our I can statement is I can use tape diagrams and the description of equivalent ratios to determine if two ratios are equivalent. So here we have a tape diagram, and here we have ratios, and we're going to be using this model to determine if those are the same. So let's watch this video.
This thing on? Okay. Our generation spends a lot of time in front of the screen, whether you're playing Warcraft, viewing your newest selfies, even watching Game of Thrones. But have you ever noticed how most screens are actually pretty similar? Here's a 42-inch TV. Here's a 24-inch monitor. And here is my huge phone. Even though the screen sizes are different, they actually look the same because they're made with exactly the same ratio. A ratio is a comparison of two things. 4 apples to 3 oranges is a ratio. So what's this mysterious ratio that links all HD TVs together? Well, let's look at some screens and see if we can actually figure it out. This HD TV has a length of 32 inches and a height of 18 inches. That's a ratio of 32 to 18. There's one compared to the other. Right now, I'm being projected on screen that is 72 inches by 40.5 inches. See, it's another ratio. And my jumbo phone has a length of 6 inches and then a height of 3.375. Even though all these ratios look different, they are all actually equal. Divide the top number by the bottom number, and you get the same answer, 1.7777777778. And that's just rounded. This is the ratio of all HD TV screens, but it's more commonly expressed by 16 by 9. See, ratios don't have to be the same numbers for them to equal the same thing. It's a comparison. One other way to check to see if you have an equal ratio is plot the points on the graph. If it forms one straight line, then you have yourself an equal ratio. So what happens if we change the ratio of the image? For example, some movies are shot in CinemaScope, which is 2.33 to 1. If you watch a movie on your 16 by 9 TV, you'll notice little black bars at the top and bottom. Why? Because the ratio doesn't match your TV. 2.33 to 1 does not equal 1.78 to 1. That's why it doesn't look the same. Another way to look at it, if you were to place 2.33 to 1 on a graph, it would not be on the same line as 1.78 to 1. But if you watch this movie at your local movie theater, you won't notice the black bars at the top and bottom. Because they changed the ratio of the screen to match the ratio the movie was shot in. Say that you're projecting a film at a movie theater. You know your height is 50 feet, because that's the height of the screen. And the movie was shot in a 2.33 to 1 ratio. So you want to know how wide do you make the screen. You can actually use ratios to figure this out. So you have 2.33 to 1 equals x to 50. To get rid of the 50 in the denominator, you multiply the right side by 50. And you have to do the same to the left side, because anything you do to the right side of the equation, you have to do to the left side of the equation. 50 times 2.33 gives us the answer, 116 and 5/10, which is also 116 feet and 6 inches. Now, let's check out the movie. I think it's a horror movie. What's it called?
So I found this weird skeleton key. Let's go check out that weird garage. Totally! Let's go.
Oh God, don't check in the closet. Never check in the dusty closet.
Rusty things are so cool! What is this?
And that's because you might find one of these lying around. This is a standard definition television, and its ratio is 4 to 3. By the way, ratios can be expressed by colon, 4 to 3, verbal, 4 to 3, or with a fraction bar. Some people refer to standard definition TV as 1.33 to 1. It's just simplified. Either way, it's outdated technology. Oh, one last thing about ratios. The ordering is super important. If you have it length length by width. 16 by 9 is not the same thing as 9 by 16. Because if it were, all movies would look like this. The cell phone screen. Probably the biggest thing that changed the ratio of the screen since it was invented over 100 years ago.
Alright, so now that we've seen an example, we're going to do a problem for you guys. So here we have, the morning announcement said that 2 out of every 7 6th graders in the school have an overdue library book. Jasmine said, that would mean 24 of us have overdue books. Grace argued, no way, that is too high. How can you determine who is right? Well, first we need to know how many students there are in the whole entire school. So we need to know the total number of 6th graders and then see if the ratio 24 to the total is equivalent or equal to a ratio of 2 to 7. So we're going to make a T-chart, overdue and total. And what goes in my overdue? Well, I see it says there's 2 overdue books, so that's going to be part of my overdue. And I see they're saying every 7, so that's going to be my total. There's 7 total 6th graders, 2 of them are missing it. And next we need to find out, well, if there's 24 overdue, how many total ones do we have? Well, what we need to do is we need to figure out what goes in here. How do I get from 2 to 24? What do I have to multiply by? Well, I know 2 times 12 is 24. And then remembering our little saying, whatever you do to the left, you have to do to the right. I have to do the exact same thing. So I look at that top number, and I do the exact same thing. I multiply by 12. What is 7 times 12? Well, I'm just going to rewrite it. 7 times 2 is 4, carry that 1. 1 times 7 is 7, plus that 1 is 8. So I have 84. So there are 84 total students at the school if the ratio is correct. Okay, so we're going to look at this. There's a mistake right here. This should actually be, and I'm sorry for that, a 24 to 84. How have we previously determined that 2 sets of ratios must be equivalent? Well, each number in the first ratio, so here's my first ratio, must be multiplied by the same positive number to determine the corresponding numbers in the same one. So what it's saying is whatever I multiply this ratio by has to be equal to this over here. So if I multiply both by 12, each of these multiplied by 12 should equal my numbers on the right side. So we're going to test this out. Since the corresponding number to 2, so let's look at our example at the top. This 2, the one it works with in our other one is this 24 over here. We multiply it by 24. How did I do that? I multiplied 2 by 12, and that gives me that 24. For it to be equivalent, I'm going to have to do the same thing to my other numbers, multiplied by the exact same number. So let's check it out. We can look at the ratios we determined, and we found that 2 to 7 is the same as 12 to 84. If we multiply 2 by 12, what we just did, and we have that 24. Again, I have that mistake up here, sorry. I must also multiply this number by that same thing, and hopefully it will become that. So what is the product of 7 times 12? Well, it is 84 like we have. Okay, what you're going to do is you're going to decide whether or not each of the following pairs of ratios is equivalent. If the ratios are not equivalent, we find a ratio that is equivalent to the first ratio. If the ratios are equivalent, we're going to tell what we multiplied them by. So let's look here. How did I get from 6 to 42? Well, that's multiplied by 7. How did I get from 11 to 88? It's multiplied by 8. So here I see that 7 does not equal 8. Since they don't equal the same, they're not equivalent. My left side was 7, and the right part was 8. So what I need to do is follow my directions now of, if they're not equivalent, I find a ratio that is equivalent to the first. So 6 times 7 gives me 42, so I'm going to do 11 times 7 so that they're equivalent, and I'm left with a 77. So here's one equivalent ratio. This one's a little bit harder. How do I get from 0 to 0? Well, I can actually multiply that by anything, because anything times 0 is 0. So let's look. How to get from 4 to 20? Well, that's easy. That's multiplying by 4. Let's check. Is 0 times 4 0? It is. So I actually multiply each side, the top and the bottom, my left and right, if I made that T-chart, by 4. So they are equivalent. And then the second part says, what number did I multiply? Well, that number I multiplied by is 4. Here's our next one. In a bag of mixed nuts and cashews, the ratio of the number of walnuts to the number of cashews is 5 to 6. Determine the amount of walnuts that are in the bag if there are 54 cashews. Use a tape diagram to support your work. So remember, our I can statement says we're using tape diagrams. So here we get into the main part of our lesson. Justify your answer by showing that the new ratio you created of the number of walnuts to the number of cashews is equal to 5 to 6. So walnuts, my ratio, it tells me right at the top, is 5 to 6. So I have 5 walnuts, 6 of my cashews. But we need to show how they are equivalent. Well, this bottom part, they're telling me there's 54 cashews. So I can say these 6 things is the same as 54. What I need to figure out now is, if this is 54, how big is this box, this box, this box, this box, this box, and this box? Well, that's easy. I have 6 boxes here, so I'm going to break them up into equal groups. When I make equal groups, I divide. 54 divided by 9 is 9. Okay, here's our important part. Notice how these boxes are the same size. This box here is the same as this box here. What do we know if something's the same? Well, that means its numbers are the same as well. So this is all 9 right up here. So how many walnuts do I have when I have 54 cashews? Well, I have 9, 18, 27, 36, 45. So if I have 54 cashews, then I have 45 walnuts. And we can see the numbers changed, but my tape diagram stayed the same, whether it's 5 and 6 or each one represents 9. They still look like the same model. Here's our next problem. 54 divided by 6 equals 9. This is what we just did. 5 times 9 equals 45, so there were 45. Here's that picture all nice and neat. And remember, this would be 1, 2, 3, 4, 5 for 45 walnuts. So our ratios are equivalent. Alright, our lesson summary. Ratios are equivalent if there is a positive number that can be multiplied by both quantities in one ratio to equal the corresponding quantities in the second ratio. So all that's saying is, if I have a ratio of 2 to 3, if it's to be equivalent to another ratio, then I have to multiply each one by the same number. So this example, they have to both be by 2. What if this was a 9 instead? Would they be equivalent? Well, let's look at our definition. It has to be multiplied by the same positive number. This one is multiplied by a 3. 3 times 3 is 9, so that part's correct, but this 3 is not the same as that 2. So they are not equivalent. Alright, what you're going to do if you are working on the laptops is your exit ticket. I'd like you to solve on a piece of paper, and then when you're done, you're going to go to AAA Math. When AAA Math is finished, you've clicked on ratios and then clicked on ratios again, and you have 50 correct, and in the green box 90% it says you may work on Khan Academy. After you have done for Khan Academy 3 sessions, so you've completed 3 of those math parts in Khan Academy, you may do typing games or math games as long as you've done 3 sessions in Khan Academy. Alright, good luck. Yep.